Hello and welcome to Solving Inequalities. Today we're going to review on what is an inequality and how do we solve that. What do you remember about them? So anyway, you need to have your composition notebook out, a calculator, and a pencil. So let's first talk about what are the differences between solving an inequality versus solving an equation. How are they the same? How are they different? On one side note here before we continue, you see a tape dispenser in the upper right hand corner of my PowerPoint here. That means I gave you a sheet of paper and you can tape it into your notes right now. And if you didn't get one or you misplaced it, you need to go ahead and draw this whole chart out into your notes. Okay, so what is the difference between an equation and an inequality? Well, the symbols are different. Equation has an equal sign. Inequalities have greater than or less than or greater than or equal to symbol signs. Steps in solving them, they're pretty similar, almost the same. You do use inverse operations to isolate those variables. But inequalities have two special rules. One, when solving, if you multiply or divide both sides by a negative number, you have to remember to flip the inequality sign. That means if it was greater than, you now have a less than symbol. So that's special rule number one. Special rule number two says you have to sketch your solutions on a number line because there's more than one solution. We need to see them on the number line. Okay, so let's go ahead and do an example. Example number one. Oh, you see a pencil in the upper right-hand corner. That means you need to take notes on this. All right, so if I'm going to solve this just like I did equations, I'm going to add and use inverse operations. Add 2x to both sides. 8x is greater than 32. Divide by 8 and I get x is greater than 4. I find 4 on my number line. I might write down a 3 and a 5 so I know that you know where 4 lies on a number line. Now, I need to say all the solutions that are greater than 4. Well, everything that's greater than 4 would be to the right of 4. But now, how do I put that on the number line so that 4 is not included? That's an open circle. Anytime we have a greater than or a less than sign, we're going to use an open circle. So open circle at 4, and then everything greater is greater than 4. And though that would be the solution and the graph of this inequality. Let's do another one. There's a pencil, so we want to write this one down as well. I'm going to subtract 6 on both sides. And I get 4 is less than or equal to negative 4x. I'm going to divide by a negative 4. Oh, I'm dividing. Special rule number 1 says that if I divide or multiply both sides by a negative number, I have to flip the inequality sign. So I get x, and I need to flip it. I'm sorry. So this says negative 1 is greater than or equal to x. So if you want to change this around so it makes more sense to you and flip the whole inequality, I'm going to put the x on the left-hand side and then I flip my inequality. I flip-flop it so that these two things mean the same thing. This says negative 1 is greater than or equal to x, which is the same thing as x is less than or equal to negative 1. I like this better because it's easier for me to read. Now I know that all the numbers that I want for this is less than or equal to negative 1. So I'm going to find 0, I'm going to find negative 1, here might be negative 2, and now I'm going to graph all the solutions that are less than or equal to negative 1. In this case, we're going to use a closed dot because we have an equal sign, and then less than would be everything to the left of negative 1. So, got to remember our special rule. When dividing by a negative, we flip that inequality sign. Then if you want to rewrite it so it makes more sense to you and what this says, put the x on the other side, flip-flop the inequality again, and then put the -1 on the right-hand side, and then graph it. So that's example number 2. Now that we have the single inequalities down, let's talk about compound inequalities. Oh no, now we can make them more complicated. Yes, they are a little bit more complicated, but not too much more. So you're given more pieces of information. Now in this one, you might see one that looks like this. It has two inequalities within the same problem. You don't need to take notes on this page. There's no pencil here. This is another example of a compound inequality. So we might have one that has the word or. Okay, that doesn't mean you can solve one or the other. No, you have to solve both. But you have the word or because your solutions could be either or. Okay, so let's go ahead and do a couple of these examples. So again, taking notes on this, solve the following inequality. Now this says -12 is less than 3x minus 1, which is less than or equal to 3. Now some people, what they like to do is they like to break this apart. And you can see that there's two separate inequalities here. Okay, and so that's really what it says. But I don't really like to separate this one when I'm solving it just because then we forget how to graph it. So I like to keep it together, but that's really what it says. It says there's two there, but they're really together. So let's go ahead and try to solve this when it's together. Now, the big idea here is that if it is together, you can see that I want to get x alone. I want to focus on getting that middle piece to just being an x by itself. So if I want to do that, I'm going to add 1 to every single side. And when I do that, I end up with -11 is less than 3x, which is less than or equal to 4. Now you can see I'm still focusing on getting that middle piece to be an x all by itself. Now I'm going to divide everything by 3. And what I do to one side, I have to do to every single side. Okay, so when I do that, I get -11 thirds is less than x, which is less than or equal to 4 thirds. I'm going to leave these as fractions. Okay, where is 4 thirds on my graph? Well, let's go ahead and see where 0 is. Here's 0. Here's 1. 4 thirds is 1 and 1/3. So it's about right here. And I'm going to label that as 4 thirds or 1 and 1/3. And it has a equal to, less than or equal to. So that's going to be a closed dot. Now let's focus on where -11 thirds is. -11 thirds is the same thing as -3 and 2 thirds. Yes, I think I did that right in my head. So -3 and 2 thirds, we would find -3, -4, -3 and 2 thirds is going to be somewhere over here. So in between -3 and -4, so right here, and it's going to be an open circle. And I'm going to go ahead and write -3 over 2 thirds. You could write -11 thirds if you wanted to, whatever you wanted to write, and make sure it's an open circle. Now, this says x is less than 4 thirds, but greater than -11 thirds. X is right in between. So our solutions would be in between because our X is in between. And that's why I don't like to separate them and solve them separately. Because if I know the X is in the middle, then I know that my solutions need to be in between those 2 points. All right, let's try another compound inequality, but this time it is that or one. So it doesn't mean I can do either or. I got to do both. So I'm going to subtract 5 on both sides. I'm going to do this one first. And then I get -9x is less than 14. And then I'm going to oops, did I subtract wrong? Oh, yep, 14 minus 5 is 9. Sorry, guys. Just making sure you're paying attention. Divide both sides by -9. Oh, dividing by a negative. That means I have to flip my inequality sign. So this says x is greater than negative 1. Or, okay, so my solutions are there, and, then we're going to do this one, and then they might be over here, okay? So now we're going to add 17 to both sides. We get negative 4x is greater than 20. Divide by negative 4. Oh, we're dividing by a negative again. So we have to flip that inequality sign, so it's x is less than negative 5. So our solutions fall either between greater than negative 1, or they are between x is less than negative 5. So we have two parts to this. So we're going to have two parts to our graph. So we're going to find 0. Now we better find negative 1, and we better find negative 5. If you need to extend your graph, that's okay. Okay, there we go, negative 5. At negative 1, it says x is greater than negative 1. So here's negative 1, open circle. Where's greater than? To the right. So everything to the right is greater than negative 1. Or our solutions could be x is less than negative 5. Open circle, everything to the left is negative, less than negative 5. So our solutions are between are are in either of those spots. That's what that means. Okay, one or the other. But we have to make sure we graph both of them on the same number line. All right, now just to make sure, this is just a summary. Inequality signs means greater than, open circle, less than, open circle, greater than, or equal to, or less than or equal to, they need to have those closed circles. So we want to make sure that we know the difference between a closed circle and an open circle. Okay, and that would be all for inequalities today. Thank you, and have a great rest of your night.